Hello everyone, myself Vinay Kumar, and today the subject which we are going to deal is DC machines and batteries. And today we are going to learn about the necessity of starter. In the previous presentations, we have learned about the various speed control methods for a DC series motor, and also I have solved some problems on that. And on completion of this topic, we will be learning about what is a starter and what is the necessity of starter for a motor, and we will be seeing the calculation of starter resistance. Starter. Starter is nothing but it is a device used to start the motor. And this starter limits the starting current, which is very large, to a safe value during starting. By limiting the starting current, it protects the damage of windings, commutator, and brushes. Now let us see what is the necessity of starter. We already know the formula for back EMFs, that EB is equal to phi ZNP by 60A, where phi is the flux generated by the magnets or field coils in Webers, and N is the speed with which the armature rotates, and Z is the total number of conductors, and T is the number of poles, and A represents the number of parallel paths. Actually, what is a back EMF? Back EMF is nothing but it is the EMF induced in the armature when it is rotating in a magnetic field. And back EMF will be zero when the motor is at standstill position, because the speed n is equal to 0 during standstill. So the back EMF will be 0 when the motor is at rest. We also know that EB is equal to V minus IARA, where V is the applied voltage and IA is the armature current, and RA is the armature resistance. From this equation, if we write the armature current IA is equal to V minus EB by RA. As I have already said, when the motor is at rest, the back EMF developed in the armature is 0, because the speed is 0, and the armature will draw a very large current. When this armature draws a huge large current, it may result in the damage to the armature and also heavy sparks will occur at the brushes over the commutator, and this deteriorate the insulation due to overheating. So this large starting current should be avoided. So in order to avoid this large starting current, a resistance is introduced in series with the armature, and this resistance is known as starting resistance or starter resistance. During starting period, we connect this resistance only up to 5 to 10 seconds, and this resistance will limit the starting current to a safe value. And when the motor gains the speed, this resistance, that is the starting resistance, is cut out, because then the back EMF will increase, and this regulates the speed of the DC motor. In this way, the starting current is limited to a safe value. Now I will be explaining this with an example. Let us consider a motor with rating 5 HP. It takes 400 volts and it has an armature resistance of 0.25 ohms, and the full load current is 50 amperes. And if the motor is started from the line directly, then it will draw a starting current of 1760 amperes. That is by dividing the voltage 400 with the armature resistance. Since there is no back EMF and the resistance of armature is low, so the starting current will be very high. In example, it is 1760 amps, and this 1760 is 35 times more than its full load value, and this excess current will blow the fuses and damage the armature windings, commutator and brushes, etc. And to avoid this, we introduce a starting resistance, represent it as capital R, which is connected in series with the armature, and this resistance limits the starting current to a safe value. Now let us see what is the value of the starting resistance which we should introduce. The armature current is equal to 400 by 0.25 plus R. R means R is the resistance to be introduced, which is equal to 50 amps. I think what? This is the full load current. Then when we solve this, we get the value of the R, that is the resistance to be introduced, is equal to 7.75 ohms. Means in this example, in order to limit the high starting current, we should introduce a resistance of 7.75 ohms in series, and this resistance is called as the starter resistance. And whereas for small motors, maybe started directly without any starter, because such motors have a high armature resistance than large motors. So the starting current will not be so high, and being small, they have very low moment of inertia, hence they speed up quickly. As the speed gets increased, the back EMF also increases. And from this presentation, we have learned about the necessity of starter, that is to limit the starting current, and also we have find the starter resistance. We have also learned about the starter for small motors. Now let us see a small quiz on this presentation. At the time of starting, the back EMF of the motor is option A maximum, option B 0, option C minimum, option D is double. So what is the answer? Yes, the answer is 0. When the speed n is equal to 0, the back EMF will be 0 because EB is directly proportional to speed. Now the second question, the starting resistance is connected in dash with the armature. Option A series, option B parallel. Yes, the answer is option A series. When we connect this in series, the resistance gets increased, then the starting current gets limited. Now the third one, the starter limits the dash drawn by the armature at the time of starting. Option A is power, option B is voltage, and option C is current, and option D, no option D, yes, the starter limits the current. Now let us see the frequently asked questions in this presentation. First one is, what is the necessity of the starter? And the second one is problem, 230-volt DC shunt motor has an armature resistance of 0.3 ohms. Calculate the resistance to be connected in series with the armature to limit the armature current to 775 amperes at starting. In the same way, the third one is also a problem to find the resistance that should be introduced in series with the armature at the starting. Now let us see the next one, that is the various types of starters. And in this, we will be learning about the working of a 3-point starter. Now let us see the types of starters. Mainly there are two types of starters. One is 3-point starter and the other is 4-point starter. Here we can observe the schematic diagram of a 3-point starter. In this diagram, let us see the various parts of starter. Here the RS represents the starting resistance. Here this is the RS. It represents the starting resistance. And L is the moving arm. This is the L. Represents the moving arm. And here this S represents the soft iron piece. And E represents the no voltage or low voltage coil. And M represents the overcurrent or overload release coil. In the terminals A, B and C represents the starters terminals. Here, since this is the 3-point starter, the three terminals are marked as A, B and C. Here one line is directly connected to one armature terminal and one field terminal, which are tied together. And the other line is, other line means here positive terminal, is connected to point A, which is further connected to the starting arm L through the overcurrent coil M. To start the motor, the main switch is first closed and then the starting arm is slowly moved to the right. As soon as the arm makes contact with stud number 1, the field circuit is directly connected across the line. At the same time, this full starting resistance Rs is placed in series with the armature. The starting current drawn by the armature with this starting resistance is given as Ia is equal to V by Ra plus Rs, where Ia is the armature current and V is the applied voltage and Ra is the armature resistance and Rs is the resistance which we have introduced. As the arm L is further moved, this starting resistance is gradually cut out till when the armature reaches the running position, the total resistance is cut out when this L reaches to the on position. The arm moves over the various studs against a strong spring which tends to restore it to off position. Then the soft iron piece S, which is attached to the moving arm, which in the full on or running position is attracted, and it will be held to the electromagnet E by the shunt current. It is known as the hold on coil or no voltage release coil. And this is the internal wiring diagram of the starter, and here the handle position is at off position, and it can be seen that as the arm is moved from stud number 1 to the last stud, the field current has to travel back through that portion of the starting resistance that has been cut out of the armature circuit. This results in slighter decrease of shunt current, but as the value of the starting resistance is very small as compared to the shunt field resistance, this slight decrease of shunt current is negligible, and this can be overcome by using a brass arc which is connected to the stud number 1, and this field circuit is completed through this arc so that the current does not pass through the starting resistance. So there are two protective devices in a 3-point starter. One is no voltage release coil, and the other is the overcurrent release coil. The no voltage release coil hold on coil is to hold on the arm in full running position when the motor is in normal position. But in case of failure or disconnection of the supply or a break in the field circuit, then it de-energizes, thereby releasing the arm which is pulled back by the spring to the off position, which prevents the stationary armature from being put across the lines again when the supply is restored after a temporary shutdown. This would have happened if the arm were left in the full on position. The great advantage of connecting the hold on coil in series with the shunt field is that should the field circuit become open, the starting arm immediately springs back to the off position, thereby preventing the motor from running away. And this overcurrent release consists of an electromagnet connected in the supply line. And if the motor becomes overloaded beyond a certain predetermined value, then D will be lifted and the terminals gets short circuited the electromagnet. Hence, the arm is released and returns to the off position. Okay, thank you very much. From this, we will be stopping this presentation.